Okay, hello there. Okay, in this video I'm going to explain to you about explain and discuss to you about Igcse physics paper, and this is paper 4, and it is the code is 0625 and is for MayJune and 2020. Okay, it's given, the time given here is 1 hour and 15 minutes. Okay, now we will proceed with the first question. Okay, now this is the first question for this paper. Okay, figure 1.1, which is this. Okay, it shows a speed time graph of a person. He walks and waits for a bus and then travel by bus. He gets off the bus and wait for 2 minutes. Then he walk again. His journey takes about this is the total time is 74 minutes. Okay, now let us look at the question. So I'm going to scroll down. So the question asks, the first question is, for the whole journey, calculate the distance travel. Okay, calculate the distance travel over here. Okay, if you notice, okay, the speed given here is under kilometer per hour. And the time given here is per minute. So make sure we have to convert the minutes into the hour. Okay, now here is 5 and here is 20. So we have to convert the, okay, now we have to find the area of the graph. Okay, the area of the graph which represents by distance. Okay, so we can use this formula, speed equals to distance over time, and then to find the distance we have to times the speed and the time itself. Okay, so we have to calculate this area to get the distance. Alright, so I'm going to erase this. Okay, now I'm going to convert the time first. We convert the time, the 20 divided by 60, you'll be getting the, okay, we simplify this, you'll be getting the 1 over 3. Alright, so it means the time here is 1 over 3. Okay, and the time here is also 20 minutes, which is about the same as this. So we just make it as a 1.1 over 3. And time here, they start with, here is 52. And then here is about 74, so which means it's 22 minutes. We convert to hours, is divided by 60, so we just make it here the time here is 22 over 60, which we can simplify it into 11 over 30. Okay, so now we are going to find, we have completed the first step, which is the changing the time to minute, and then we multiply with the speed. Okay, so 1 over 3 we multiply, let's say we just make it as a 1 over here, and this is a 2, and this is 3. So the first one, the calculation here will be 1 over 3, which is the time, multiply with 5. Okay, this is speed. Okay, and then the second one here will be 1 over 3 multiply with 40, and then the third one here we have the time, which is from here 11 over 30 multiply with, okay, this is slightly above, so it's multiply with 6. Okay, alright, so we are going to make all this, add all this. Okay, so we are going to add all this 1 2 3 to find the total distance. Okay, let me scroll it down. Okay, so you can see here the distance traveled here, 1 over 3 times with 5, and then we plus with number 2. What is number 2? Number 2 will be 1 over 3 multiplied with 40, so 1 over 3 multiplied 40, and then we plus again with this number 3, which is 11 over 30 multiply with 6. Okay, so we are going to plus this and we will be getting the answer. Okay, the answer is 17.2. Okay, 17.2, and make sure you write the unit. The unit is a kilometer. Okay, because we have converted the time to hour and we are using a kilometer as well. Okay, so we have obtained the first answer for the first question, and this is a 3 marks here. Okay, now we are going to do this A2. So they are asking for the average speed. Okay, average speed, they have a calculation here. The total distance divided with the total time. So we have actually managed to obtain the first one. Total distance is 17.2, and the total time is actually given in the question. Let us scroll up here. Okay, as you can see here, okay, this part, his journey takes about total 74 minutes. Okay, 74 minutes. So here what we are going to do is 74 minutes. Okay, it's a minute, so we have to divide it by, this 74 divided by 60. So you will be getting the answer. Okay, we just have to put here 74 divided by 60. Okay, when you calculate this, we will be getting the answer 13.95. Okay, 13.95. Okay, not forgetting the unit, so you just have to put here kilometer per hour. Okay, that is a 2 marks for you. Alright, let us move to the next question. Now this is the next question. The B, state and explain which feature of the speed time graph shows acceleration. So normally if you have a speed and time graph here, speed and time, the gradient is actually shows the acceleration. Okay, the gradient. So they asks us to state. So you just have to state here the gradient, and then you can write down the formula here. Okay, explain gradient is actually equals to change of the speed. Okay, change of the speed over the time. Okay, this is the answer for the B, which is 2 marks over here. Okay, and then I state and explain the acceleration of a person at time 40 minutes. Okay, let us go through the graph again. So when it is in 40 minutes, okay, you can see draw it with a yellow color. Okay, you can see it's 40 minutes over here, this part. So 40 minutes, he is actually traveling in a constant speed. Okay, it's a constant speed. So now I'm going back to the question here. Okay, state and explain. So you will be having a 0. Your acceleration of the person at 40 minutes, okay, is 0. Okay, why 0? Because he is actually traveling at a constant speed. When you have at a constant speed, the acceleration will be 0. Okay, it's a constant speed. So there's a 2 marks over here. So we have successfully completed the first question, which total up 9 marks. Now we are going to the second question. Okay, this is the second question. Okay, now this is the train. Okay, total mass of the train and passenger is 750,000. The train is traveling at a speed. Okay, this is the initial speed. Just put the U. The driver applies brake, and the train takes 80 seconds to slow down to speed 42. Okay, first is they asking the impulse. The impulse can be written as Ft, force multiplied with the time, mv minus mu. So here we can factorize the m, 750,000, and then your final velocity here will be 42 minus with your initial velocity, which is 84. Okay, so your impulse is actually equals to, you are getting the answer is 3.15 times to the 10 to power of 7. And make sure you put here negative. Okay, this is from the calculation. Okay, but when you look at here, it's applied to the train. When it is applied to the train, you can actually ignore the sign negative, and your impulse here is 3.15 times 10 to power of 7, and your unit for this force is Newton, and unit for the time is seconds. So we can just put here Newton seconds. This is 3 marks. Okay, now let us move to the next question here. Okay, they are asking to calculate the average resultant force applied to the train. So we can use this Ft equals to 3.15 times to 10 to power of 7, and we just have to move the time. Okay, we just have to move the time to the opposite. It will become a divide over here. Okay, once it becomes divide, so you can go back to the question here. They mentioned takes 80 seconds. So 80 seconds. You will be getting a average resultant force. Okay, so your force here will be, according to the calculation, so you got the 39375 Newton. Okay, this is your answer for the B. Or you can just like you can write it down, this question, this answer what you get. Okay, this is a 2 marks over here. Okay, so we move to the next question over here. Okay, we have suggest how the shape of the train helps it to travel at a very high speed. Okay, this one we call it as an aerodynamic. Okay, they have a shape of an aerodynamic. Okay, this is one of the answer. Okay, the second thing is what you can say is the shape actually reduces the shape name. The name of the shape is aerodynamic, and they're asking suggest how the shape of the train helps it. So it reduces air resistance, or we can say it's an air drag. Okay, it's 1 mark here. Okay, the train took 80 seconds to reduce its speed from 84 to 42. Explain why with the same braking force the train takes more than 80 seconds. Because when the train is traveling at a very high speed, they have two resistance. One is the braking system itself, and also the air resistance. A strong air resistance will help the train to slow down. But when you're traveling at a lower speed, you will have less air resistance. So this air resistance couldn't help much to reduce the speed of the train, okay, to 0. So this is your suggested answer. Okay, and then the last one here. Okay, last one. On a wet day, a train travel at a greater distance before it stops. Okay, it has the same speed of 84 before the brake are applied. So to solve this question here, suggest a reason why it travels a greater distance before it stops. You can say because when it is on a wet day, the friction is lesser. So you can see the friction force here, friction force between the train and the rail. Okay, rails are reduced. So this one is your answer. Okay, this is for 1 mark. Okay, now we move to the next question. Okay, this is the third question here. Okay, solar panel receives energy from the sun at the rate of 5000 watt. Okay, this one is the input power. Okay, this is a power input. So this is 5000 watt. Okay, and then here the thermal energy is transferred from solar panel to the water at the efficiency of 20. So this is the mode to energy. So the energy formula, efficiency formula will be energy out over energy in okay, and then we multiply with 100, and this is equals to the efficiency they mean, which is a 20%. Okay, and then specific heat capacity of the water is 4200 and temperature increase. For these two, we can use this formula MC and theta. Theta means is the temperature changes, and the C we have a value of 4200 of the water, and M we can be 15. Okay, 15 kg. And now we have to be very sure about this energy change. Alright, so now the power input here, we have to change it to energy input. So this power is normally per second. Okay, is for 1 second. Now they mention is for every hour, right? So 1 hour has about 3600 seconds. So the energy input, the energy and power formula is power equals to energy over the time. And the time will move here, it becomes multiply. So energy in equals to the power multiply with the time. So the energy in here is the power, which is your 5000 multiply with 6600. This is the energy in. Okay, so when we calculate this value, we will be getting 5000 times 6000. So to calculate the energy out now, so what we're going to do is the 100 will move here, it becomes 0.2, and the energy in will move here, it becomes energy in multiply with 0.2. This is the energy out. This is the energy that transferred to the water. Okay, so now we have to find this. Okay, the energy out here will be 0.2 and multiply with 5000 multiply with 3600. So your energy out value here will be 3.6 times to the 10 to power of 6 joule. Okay, this is the energy out. This energy out is the one which is equals to this. This is the energy that received by the water. So 3.6 times to 10 to power of 6. Okay, M is 15 and the C is 4200, and your theta here is what we are going to find. So this value will be divided by 15 times with 4200. Okay, your final value of the temperature increase here will be, give me a second, 15, 4200. So it will be, okay, this one, the value is 57.14. Okay, that's the answer here, guys. 14 degrees Celsius. The unit is already written here, and we are getting here 4 marks. Okay, now we continue with the question. Okay, now they mentioned that state one advantage and one disadvantage of heating the water in solar panel. Okay, the advantage here when we are using a solar panel is it is a renewable energy. Okay, it is a renewable energy, and your explanation here, the main explanation when we are using a renewable energy is there is no pollution. Oops, okay, so got here pollution. Okay, this is your answer for advantage and the explanation. Disadvantage, okay, so disadvantage is to install a solar panel or solar related system here is expensive. So your startup cost here will be expensive. So you just write down here expensive to install. Expensive to install. No, I forgot another L. Okay, this one could be explanation. You can also say that it needs a suitable roof to install the solar panel. Okay, so this is your 4 marks here. Okay, we'll move on to the next question. Okay, this is the 4th question for this paper. Okay, now it is a liquid in glass thermometer temperature scale. It has a melting point of, it's quite low. Okay, a simple experiment to mark the position of the fixed points. Okay, the fixed points, so here we don't have any scale reading over here. So the best thing you can say is, for number 1, we place it in melting ice. Okay, melting ice, so that you can get 0 degree Celsius. Okay, you have to mark it. And the second thing is, you can place it in boiling hot water, because boiling hot water you will be getting 100 degrees Celsius. Okay, so you can actually add on a point over here where you have to mark both or you can say label both points when the mercury stops to move. Okay, this is your 3rd point. It can be, okay, so it is applied to both, so you'll be getting here 4 marks for this. Okay, and then in additional point here, you can also measure the length. Okay, measure the length between 100 degrees Celsius to 0 degrees Celsius to 100 degrees Celsius, and small small label or the scale. Alright, the scale can be calculated. So this is under calibration of a thermometer. So this is an additional point here. So we already have 4 marks here, this part. Okay, we move on with the next question out here. Okay, scientists measured a scientist measuring temperature at South Pole, and this temperature have a minimum value of, this is a minimum, so it means it can go below than this value. So why this liquid is not suitable? Okay, why? Because you can see that here they already mentioned the melting point here is a negative 39, and here the temperature is 90. So you can say that is it mercury? Okay, you can say that the liquid inside the thermometer here, okay, when the liquid inside the thermometer will be solid. Okay, so state a design change that increase sensitivity. Okay, you want to increase the sensitivity, we can use a smaller bulb. Okay, smaller glass bulb. So when it's a smaller glass bulb means is here we have to make it this size smaller. Okay, when it becomes much more thinner, it is much more sensitive to the outside. Okay, so to increase the range, if you want to increase the range, you need to have a larger glass bulb. I am talking about this volume. So when you have more volume, more liquid stored at this part, it means it can go further higher, and your range will be much higher. Okay, now we look at the D here. Property of the liquid: ensure the scale is linear. So your answer here will be expanding uniformly. Okay, with temperature. You can actually add on over here. Alright, so we have completed this question, question number 4, and this is the 8 marks over here. Okay, now we'll move on to question number 5. Okay, this is the 5th question here. Okay, the crest of the wave approaching a barrier where the wave will be reflected. Okay, so okay, this is the direction of the wave and crest. Okay, now we look at the question here. They mention, first one, draw 3 crests on the reflected wave. 3 marks. Okay, so what we can do over here is we just have to draw a straight line. Okay, straight line. So I'll maintain with this black color. So we draw a straight line. So mine is not that straight because I'm using a pen tablet, but always have to remember the direction, and the crest here must be a 90 degrees. Okay, always 90 degrees. And then here you have a normal line at this barrier. So it should be straight 90 degrees. And here you have the angle. You have this angle. So for reflection, the angle must be the same. Okay, so angle must be the same. So this is the angle, let's say is X, angle X, and you have to draw the same angle exactly at this your reflected. waveform. So this is your reflected wave. Okay, this is the reflected wave, and you will have the same angle over here. Okay, must not change the angle. And then you have to draw this crest. So the crest, make sure you have a 90 degrees over here. So you'll be getting, you can start from here, this part. So you'll be getting a straight 90 degrees. Okay, so another one, 3. So it is not 90 degrees. So you can draw. So make sure here you use a ruler to draw a straight line, and it is a 90 degrees attached. Okay, so this is the crest. Okay, so this is the answer for the first question. Okay, draw 3 crests. So you'll manage to get a 3 marks over here. And the next question here will be B. The wave has a wavelength of 36. Okay, wave lambda. Wavelength is a lambda, so 36 centimeter. So it is a 0.36 meter, and you have a speed. The speed is v 1.2. So we can use this wave equation here to sort out this problem. 1.2 and your frequency times with 0.36. Okay, then we divide here. So your frequency will be 1/2 divided by 0.36. Okay, let us see this is how much. Okay, so you'll be getting the 3. Got it. Okay, so you'll be getting the 3.33 Hz. So this is your answer here, has 3 marks. Okay, and echo is the name of a reflected sound wave. The wave that form an echo are type of longitudinal. Yes, all sound is a longitudinal wave. Longitudinal are made of a compression. So you have a compression and also these rarefactions, C and R. So this is your total 8 marks there. Okay, now we move on to the next question. Okay, this is now as a question number 6. So we have an angle arrangement of a glass prism. Angle of the prism are this one. Okay, this is, I think we are asking. Okay, so here you can see total. Okay, incident ray of the light undergoes total internal reflection in the prism, and then complete the path of the rays through the device. Okay, so it is coming from here, so which means you'll be hitting here, this part, and make sure you have this this line here. This is we call as normal line. So you will hit on straight to the next prism. Use your ruler. Okay, you will hit here. You can draw the same thing, the normal line, and you will hit direct to the eyes. Okay, this is the drawing, guys, and you can put the arrow here just to avoid confusion. Okay, so this is 3 marks. There's a 3 marks over here. Okay, refractive index of glass. Show that. Okay, they're asking us to show that. So the formula for refractive index with the critical angle is n equals to 1 over sine c. It's 1 over sine 45. When you calculate this, yeah, you'll be getting the answer. N is, or you can write it over here, is 1.41. So it's shown. Okay, shown. So you got the 2 marks over here. Okay, so I think that's the question. So you got a total 5 marks from this. So next we'll move on with the next question. Okay, this is the question number 7. Okay, so here I just said, okay, so here a student makes a transformer that uses AC with 12 volt to induce an output. So it means it is a step down. So it is a step down transformer, complete to show transformer connected to the supply and the output of the transformer. So you can say output of the transformer. So this is a sign of the AC. Okay, just have to connect this. So make sure you have like more coils over here. Okay, so more coils. So you can see the add-on here a little bit. Okay, so make sure then it's connected to your supply. So this is a 12 volt supply, and then your output here must be lesser coil. So we just make it into here lesser coil, and this is 2 voltage. Okay, this is a 2 voltage. So this is how your answer is. This is 3 marks. Okay, now they are asking, move bit. Okay, now they are asking explain the function of a piece of iron. So this is the piece of iron here. Okay, this one, the function of the piece of iron, is to link. Okay, to link. Okay, number one is to link the magnetic field from the primary side to the secondary side. Okay, this is one of the function. Another function is to provide oops, okay, so it's to provide better magnetic field, or better or stronger. You can see I think stronger is better, stronger magnetic field. Okay, so that one will be the best answer for these 2 marks. Okay, and then you have a calculation here. Output of the transformer connected to the lamp. Okay, transformer is 100% efficient. It means that there is no power loss here. Okay, you have no power loss. Current in the lamp is 100 millimeter. So input current. So we can use this IPVP ISVS since it is a ideal case. So in this case, current in the lamp output. So this is the output. This is secondary. So here we have 100 milli. So it's 1, 2, and 3. So you got there 0.1, and here, oops, there's a wrong sign over here. Okay, this one I should write it as a VS. So here will be 2, and the input voltage is 12. So it's 12. Okay, input voltage is 12. So here's 12, and input current is, I'm not sure. So here will be 0.2 divided by 12. This is your input current. So input current here will be 0.2 divided by 12. So you'll be getting there 0.017 ampere. Okay, so the B here, another transformer is used in the school laboratory to step down the main supply with this. Okay, this transformer is mounted in a metal case. Okay, state and explain safety features. So you have to make sure the metal earth is, a metal case. Oops. Okay, the metal case is actually earthed to avoid shock. Okay, and then you have to make sure the wires wire is insulated. Okay, so that is the explanation here. So this is 9 marks in total. Okay, let us move to the next question. Okay, this is question number 8. Okay, this is we have a LED, a diode that emits the light. Okay, draw a circuit showing an LED connected so that it is lit in series with the battery and a fixed resistor. So we can use batteries. Maybe we can use one, and then here there is a resistor attached, and here we have a diode. Okay, this is the diode symbol, and make sure it is going up like this. Okay, it shows it is a LED. Okay, so this is the 4 marks. Okay, so now we have question B8. Potential difference across the LED when it's lit is 3.1. Current is this much. Value of resistance. Okay, this is just have to use this. V equals to IR, and then the V will be 3.1, and the current value here will be 0.03 resistor. So to find the resistor, you just have to divide 3.1 with 0.03, and we'll be getting the answer. So R is 103.3 ohm. Okay, so you got here like 2 marks over here. Okay, now we have questions. Okay, C shows a power supply of a 10.5 connected in series with a lamp and a heater. So across the lamp is, okay, this is the lamp. Across the lamp is 2.1 voltage. Current in the lamp here is 1.5 ampere. So to calculate the resistance of the heater, okay, so in series normally is voltage 1. Okay, this voltage and this voltage we have to add up. So this is a voltage of heater plus with 2.1, this voltage must be equals with the supply, which is 10.5. Then here 10.5 you minus with 2.1, we are getting the voltage of the heater, which is 8.4. 8.4. Okay, this is the voltage. So this 8.4, since it is in series, so in series the current will be the same. Okay, even here the current will be the same, 1.5 ampere. So to find the resistance here will be much easier. Voltage is 8.4 divided with the current 1.5, and your resistance here will be getting the 5.6 ohm. This is the resistance of the heater. Okay, now power of the heater we can use PVI. So which means the voltage of the power heater is 8.4, and then bracket here you'll be getting the current 1.5. We multiply this and we'll be getting 12.6. So this is a 12.6 watt. So we got here total 2 marks, 2 marks, and here is 10 marks over here. Okay, we move to the next question. Okay, this is a logic gate question, number 9. Okay, it shows a NAND gate. Okay, in case you forget about this NAND gate, please remember AND gate. Okay, so we have let's say we put another column here. This is for AND gate. So the output here will be, this is output here. This output, so here will be 0, 0, 0, and 1. So when we attach to a NOT gate over here, so the AND gate basically is a AND gate. They attach with a NOT gate at the end. So whatever the results must be opposite. So you'll be getting here 1, 1, 1, 0. So your output here will be 1, 1, 1, 0. So that's how I remember the things. We got here 1 mark. Okay, now we proceed with this. Okay, as you can see here, this part, okay, 0. Okay, this is the AND, not AND, it's OR. Okay, C is OR. This part is the OR gate. Okay, based on the results over here. So the OR gate is, okay, let's say I just put here OR gate. OR gate, the output of the OR gate will be either 1 must be 1. Either one of the input must be 1. So it'll be 0, 1, 1, 1, which is this. And here the D represents the AND gate. Okay, just memorize this. Okay, and then here the E output. Here will be, okay, this is NAND gate. Okay, as you can see here, the symbol here, X and X, so it is a OR gate. So OR gate, either one of the input is 1, and automatically the output will be getting 1. So your answer here will be will be 0, 1, 1, 1. Okay, this is say following the OR gate. Okay, now deduce the name of the logic gate Y. So Y is the AND gate. Already completed. Done. Done. Okay, now we move on with the last question of this. Okay, now we have a current here. Okay, how many electrons pass through copper wire every 60 seconds? So we have the formula for the current is a charge over time. So we have the IT. So your total charge over here will be, charge is 3 multiplied with 60, and you'll be getting here 160 coulomb. Okay, 160 coulomb. So for 1 electron, you have 1.6 times to 10 to the power of negative 19. This is coulomb. So we need to get 180 coulomb. So how much is your electron? So how much we are going to multiply here? So what we are going to do here is, we just have to take 180 divided with this. Okay, so this is the steps over here for this, both of these, and we'll be getting the answer. So the answer is 1.1 to 10 to the power of 21 electrons. Okay, this is the question number 9. It's total 7 marks question. Okay, this is the last question for this. Radioactive source emits alpha, beta, gamma. It's very strong magnetic field. Okay, so we have a lead cylinder with narrow central hole. Okay, state and explain Okay, this one is to make sure the beam, okay, the beam of rays to move in one direction. So all this alpha, beta, gamma will be passing through here. Boom. Okay, then we have alpha, beta, and gamma. They pass through this magnetic field. Explain your answer. Okay. Here there is a small explanation from my part. Okay, first you have to understand the basic concept of alpha, beta, and gamma. Okay, alpha is 4,2 helium, which is a positive charge. Electron is 0, -1. Electron is a negative charge. Gamma is neutral. Okay, gamma is neutral. So gamma will pass through without any deflection. This is gamma. Okay, now north pole has the same effect of a positive side, and the south pole has the same effect of this negative. So the alpha will be reflected toward the south. This is alpha. However, the beta is a negative charge electron, will be deflected toward the positive. So this is the beta. But in actual, their path will be here slightly deflected. Okay, this is the beta. Alright, so we just have to explain this answer over here, this part. So we can actually explain your answer. Alpha is 4,2 helium and it is a positive charge. It will be attracted toward the positive charge will be attracted toward the south pole. Okay, so you just have to do your own sentence. Okay, beta is a 0, -1. Electron is a negative charge and it will be attracted toward the north pole. Okay, however, this one gamma ray is a electromagnetic radiation. So they are neutral. So there is no deflection for this gamma ray. Okay, so we have completed all this with your 8 marks over here. So we have successfully ended the paper. So I hope you enjoy the video, and please like this video, subscribe the channel, and also please pass it to your friends and other students so they can get a much more exposure. If you have any questions, please leave a comment in the YouTube video. Thank you very much, guys.